Start, please.
A very pleasant day, everyone. This is K. Srilekha from CSWRS Center of Excellence, Khammam, here before you to present a topic in mathematics. So, before me entering into today's topic, I heartfully want to thank our Secretary Sir, Dr. Praveen Kumar, for providing me such a wonderful opportunity where I can expose my talents and break down all my fears. We are very gifted to have you, sir. Thank you. Thank you so much. Now, let us enter into our intro. We all might have seen Taj Mahal, Tiruvannamalai, and other monuments in our childhood. Yes, we do. They are stunning, beautiful, aren't they? Yes, they are. So, what do you think is the reason of their beauty? What makes them look across beautiful? Yes, it's symmetry which makes them look atmos beautiful, which is today's topic, symmetry. Now, coming to the definition of symmetry. When one figure seems identical to another figure, when we flip it, slide it, or turn it, then those two figures are said to be symmetrical in nature, and this property is called as symmetry. Now coming to next term, which is line of symmetry. As you can see in the above slide, that on the Taj Mahal, there is a vertical imaginary line which is dividing this figure into two identical parts. So this imaginary line which divides the figure into two identical parts is said to be line of symmetry. This line of symmetry judges us what type of symmetry that the above figure projects. Now, coming to the types of symmetry. In today's class, we are going to learn in detail about line of symmetry. And you can also observe a chart there in which there is a vertical line which divides this chart. When we fold this chart, you can observe that there's a vertical line which divides this chart. So this is an imaginary line, and this line is said to be line of symmetry, as I told you earlier. Now coming to the next topic. This line of symmetry is also called as mirror line. For example, coming to the live example, here you can see me that I have drawn a half-sided butterfly. You can see a half-sided butterfly here. And in this butterfly, when you place a mirror and look at this butterfly, the object which is before the mirror and the image which is found behind and in the mirror seems to be identical. It completes the figure. So in this way, symmetry is also used in mirrors, and the surface of the mirror here is said to be mirror line. And you can also see there is a dragonfly there. And of course, it's a painting. When you see that, when you have paint half side of the dragonfly, and when you fold the paper, you can observe that exactly the line which is at the center divides this dragonfly into two identical halves. So this line is said to be mirror line or line of symmetry. Now coming to the types of line symmetry. The first topic. Coming to the types of line symmetry. Usually we do have three types of line symmetry, which is vertical, horizontal, and diagonal. So in the above, as a PPT which is shown here before you, you can observe that under the vertical symmetry, you have a pot. You can see a pot. And there is a vertical line, dotted line, which divides this pot into two equal halves. So if a vertical line divides the figure into two identical parts, then it is said to be vertical line symmetry. In the same way, you have an arrow there. The arrow is in the horizontal way, and there is an imaginary line which is drawn in a horizontal way on the arrow, which divides this arrow into two equal halves. So if a horizontal line divides the figure into two equal halves, then it is said to be horizontal symmetry. In the same way, we have a star there. In that star, if you make a line diagonally, then that diagonal line divides this star into two identical parts, as you can see. So, if a diagonal line, diagonal line divides the figure into two identical parts, then that type of symmetry is said to be diagonal line symmetry. Yes, I hope you're clear. And to make you more explain in a more detailed way, I've got you some live examples, which is a triangle here. You can observe that the figure in the triangle has a vertical line. What does this vertical line represent? Yes, it is the line of symmetry. And this is an example for vertical line symmetry because there's a vertical line which divides this figure into two identical parts. Yes. Then coming to the next example, which is a example for horizontal line symmetry and also vertical line symmetry and diagonal line symmetry. Yes, let us consider it as an example for horizontal line symmetry. If you make a line in a horizontal way, if you fold it, then you can observe that it exactly coincides. It divides, this fold divides this square into two equal halves, into two identical parts. So this type of symmetry is said to be diagonal symmetry and horizontal symmetry also. If you divide it in a diagonal way, then it's going to become diagonal symmetry. In the same way, there is another figure. You can observe a rectangle here, and this rectangle, a notice a rectangle is only vertical symmetrical and horizontally symmetrical. A note, it is not diagonally symmetrical because when you try to fold this rectangle, it doesn't coincide. I mean, the diagonal part doesn't divide this rectangle into two equal parts. So this rectangle is not said to be diagonally symmetrical. And coming to circle, we can draw infinite symmetrical lines for a circle based on the size of the circle you take. So here are some examples for line symmetry and types of line symmetry, vertical, horizontal, and diagonal. Now coming to the next topic, which is mirror symmetry. As shown in the PPT, you can see a word there, but can you see it properly? No. Now try keeping a mirror in front of the object, in front of the word there. Yes. Now we can see that is reflection. So from this, what can you conclude? There is lateral inversion which is taking place between the object and the mirror which is formed inside the mirror and the image which is formed inside the mirror. So how can we define mirror symmetry? If a mirror divides a figure into two identical parts, then it is said to be mirror symmetry. You can observe yourself in a mirror. Rather, you can take a square or a circle as shown in the figure. There is a mirror and a square is objected in front of the mirror. You can observe that the square which is present before the mirror and the image of the square which is formed inside the mirror seems to be identical. Respective of the size, edges, angles, and the number of faces they have, they seem to be identical. And there's a circle too. And in that circle also, you can find that seems to be identical with the image and the object. So this kind of object, which look alike, the object and the image, then these objects are said to be mirror symmetrical, and this symmetry is said to be mirror symmetry. So let's see some more examples in our daily life. So coming to alphabet, have you ever tried looking at alphabets in a mirror? Yes, you might have seen. But few alphabets resemble alike when they placed before mirror. I mean, they seem to be identical. Whereas other few alphabets which are not identical, which are lateral inversion. So now I'm going to read out which are on the screen. You have alphabets A, H, I, M, O, P, U, V, W, X, and Y. This kind of alphabet in which they are placed before mirror, then they seem to be identical. So these kind of alphabets possess symmetry. Yes, I can say that because they seem to be identical when placed before mirror. Yes. And what about alphabets such as B, C, D, E, F, G, H, K, L, M, etc., which are not mentioned earlier? Yes, they are non-symmetrical with respect to mirror. Yes. Now, if you go to other examples in our daily life, you can see ambulance. Yes. Have you ever observed ambulance? The word ambulance on the vehicle is written in a way of lateral inversion. Why is it written in a way of lateral inversion? Have you ever doubted why is it written? Yes, now I'm going to tell you the reason. Because the vehicles which are moving on the road have to understand that there is an ambulance present behind them by looking into the rearview mirror. Because the rearview mirror gives lateral inversion. If you write this ambulance in a way of lateral inversion, then it looks exactly clear in their rearview mirror. So this is the reason behind the print of ambulance in a way of lateral inversion on the vehicle. Yes. Here is a daily life example. And in this generation, most of our problem is we just understand the way to solve problems, the way to read concept, but that's not the issue. You have to understand. You have to understand the practical way and applications of this mathematics in our daily life. So now I'm going to show some applications of my topic in our daily life. How can it be applicable? So coming to the first application, which is art. Yes, we might have seen Rangoli on the day of festivals, etc. And did you observe the dots which are placed are exactly identical? There is equal space between each dot. So this is, I mean to say that this rangoli is said to be symmetrical, whether it's vertical, horizontal, or diagonal, but it is symmetrical. So what makes a figure or an art look beautiful? Yes, it's round. It's symmetrical, which makes them look beautiful. Now coming to the second application, which is architecture. Yes, as I told you in my introduction, we all might have seen some monuments like Lal Killa, Taj Mahal, and etc. Monuments in our childhood. And these look stunning beautiful, as I told you. It's only symmetry which makes them look beautiful. If they are constructed in a next way, that's not in a symmetrical. One is big, one is large. They don't seem to be identical. Then that doesn't look beautiful, of course. Then coming to the third example, which is textile designing. Have you ever observed clothes? Our clothes which have designs, and one design seems identical to the next design which is on the clothes. Yes, here is an application of symmetry in textile designing. Yes. Coming to the next example, which is nature. Yes, nature is also a best application of symmetry. You have a sunflower there shown. That sunflower and the petals which are present on the stigma are identical to the rest of the petals. What I mean to say is one petal is symmetrical to all the petals which are present there, and this makes that sunflower look beautiful. Yes. And you can also see a butterfly there. The left wing of the butterfly and the right wing of the butterfly are exactly identical. I mean, when we just fold them, they seem to be identical. So here is an application of symmetry in nature. And we also have its application in science and technology. Yes. Now, let us have a small recap of what we have learned about symmetry, mirror symmetry, etc. in today's class. The first thing we have learned is what is symmetry. When one figure seems to be identical to next figure, either we flip it, fold it, or turn it, then that property is said to be symmetric. Coming to the types of line symmetry, there are three types mainly: vertical, horizontal, and diagonal. If a line is drawn vertically, if it divides into two identical parts, then that figure is said to be vertically line symmetrical. In this way, horizontal and diagonal too. I've showed you some live examples also. Now, coming to the next one, which is mirror symmetry. So what is mirror symmetry? It's a mirror. If the object and image seems to be identical in a mirror, respective to their angles, edges, and sides, then that is said to be mirror symmetry. And we have also learned about the applications of this symmetry in our daily life, which is, let me remind you once again, art, architecture, textile designing, nature, science, and technology. Yes, this is my class about mirror symmetry. Now let us enter into next part. So let me introduce and let me pose a question. What makes us look at things around us? What makes us look at things? Obviously, you would answer me that it's eyes, which makes us look at things around us. Yes, I am not against you. It's eyes which make us look at things. But will these eyes make us see objects in dark? Will these eyes make us see objects in dark? No, it's only the luminous objects which make us look at things. Yes. Now coming to the definition of luminous body, you can see a light there, a light, a sun, stars, etc. These are said to be luminous bodies. I mean, the objects which can emit their own light are said to be luminous objects. And then what about chair, wood, glass, human beings, etc.? What are we? Yes, we are non-luminous bodies. Coming to non-luminous bodies, objects such as Earth, Moon, human beings are non-luminous because we cannot emit our own light. So we are called as non-luminous bodies. Then I give you a statement that moon is non-luminous, then you can pose me a question that if moon is non-luminous, how can it emit its own light during nighttime? Yes, even I have this doubt, but the answer is moon does not emit its own light. It only reflects the light which is incident on its surface. Yes, which is today's topic, reflection. Coming to reflection, now I'm going to tell you about the phenomena of reflection. Coming to reflection, what is the phenomena behind reflection? So here we have a plane. This is a plane, namely, and here is the normal to the plane. Here is the normal. And remember, this normal exactly makes 90 degrees with the plane. Then let us assume that there is a source here. Yes, there is a source, and the light rays are incident on the surface from the source. So these light rays are called as incident rays, denoted with I. So when some rays are incident, they definitely get reflected. So here is the reflected ray. And it is denoted with R. So what else? We have something called angle of incidence and angle of reflection. So the angle which is present between the incident ray and the normal is said to be angle of incidence, and it is denoted with angular I. So the angle which is present between the incident ray and the normal is called as angle of incidence. In the same way, the angle present between the reflected ray and the normal is said to be angle of reflection. So, and the angle between the incident ray and the plane, we can assume it as any constant, let's take alpha here, alpha 1, and the angle between the reflected ray and the plane can be assumed as alpha 2. So this is the phenomena. As you can observe in the figure, see, this is the last picture. There is a chair there, and the light rays from the source first will be incident on the chair. Once they are incident, they definitely get reflected. So that they get reflected from the surface of this chair, and then these reflected rays strike our retina so that we can look at things around us. So this is the phenomenon of reflection. Now let us see something which is very important, which is the laws of reflection. Laws of reflection. We generally do have two laws of reflection which are as most important and prominent in solving higher level questions. Yeah, the first law is angle of incidence is equal to angle of reflection. Yes, angle I is equal to angle R. This is the first law of reflection, and this is very important. Now, let us see the figures. What I mean to say is the angle with which the ray is incident and the angle with which the ray is reflected will be equal, always. These two rays, these two angles will always be equal. So here is the first law of reflection. Now let us enter into the second law, which is the incident ray the reflected ray and the normal always lie on the same position. Is it clear? Let me tell you again. The incident ray, which is the incident ray, the reflected ray, and the normal which makes 90 degrees is always lie on the same plane. Yes, this is the second law of reflection, which is The incident ray, the reflected ray, and the normal always lies on the same ray. Okay, this is something about reflection of light in a detailed way. Now, let's have a small recap of what we learned in today's class about reflection. Yes, the first thing is definition of reflection. What is reflection? The change in direction of the light rays or bouncing back of light rays from one medium to same medium is said to be reflection. Yes, this is reflection. And we have also learned about luminous bodies and non-luminous bodies. Let's define them again. The bodies which can present their own light, which can emit their own light, are said to be luminous bodies, and the bodies which cannot do so are called as non-luminous bodies. Let us note some examples. Sun, star, etc. is said to be luminous, and human beings, moon, earth, which cannot emit their own light, are said to be non-luminous bodies. Yes. Then what else we have learned? We have learned something about phenomena of reflection and the terms about reflection, which is the incidence rate, which is incident on the surface, and the normal, which is and remember, this normal exactly makes 90 degrees with the plane. Yes. The next one is angle of incidence. The angle which is present between the incident ray and the normal is said to be angle of incidence, and the reflected angle, that is angle of reflection, which is the angle presented between the reflected ray and the normal is said to be reflected ray or angle of reflection. Now, we have learned about some important things which are called as laws of reflection, which is the first law tells us that angle of incidence is always equal to angle of reflection, which is what? The angle present between the incident ray and the normal is always equal to the angle present between the reflected ray and the normal. This is first law of reflection, which is very important. Coming to the second law, which is, let's assume this as plane, the incident ray, the reflected ray, and the normal always lies on the same plane. Yes, the incident ray, the reflected ray, and the normal always do lie on the same plane. Yes, this is something indeed about reflection. Now, let us not make any delay and let's solve one problem based on reflection. Just a small problem on reflection. Okay, let me write down the question. Question is, let me read it out and let me make you get understand it. The first thing is, the angle presented between the incident ray and the normal is 30 degrees. Yes. And then find out the angle presented between the reflected ray and the plane. Let's draw a figure and make you understand in a clear way. Yes. Let's draw the figures. According to this question, there is a ray which is incident and the same ray got reflected as usual. Incident ray, reflected ray, and this is normal. This is the angle of incidence. This is the angle of reflection, and this is the plane T, normal, and which makes 90 degrees. First, let us recall what we have learned. Yes, the question is, the angle made by the incident ray and the normal is 30 degrees. What is the angle made by the incident ray and the normal? Yes, it is the angle of incidence. So let us write given. Angle of incidence is given as 30 degrees. So let's mark it. It's 30 degrees. Let's hope it's clear until then. Now the question is, angle between the reflected ray R and plane. They're asking us to find out this angle. So let us assume this angle as X. Let the angle between reflected ray and plane be X. Yes, this is the angle which we have to find out. So how can we solve such sort of question? Yes, let me do it for you. One. So by using first law of reflection. By using first law. What can you conclude from the first law of reflection? Yes, angle of incidence is always equal to angle of reflection. So here they have given us angle of incidence is 30 degrees. Then what about angle of reflection? Obviously it's 30 degrees. So angle of reflection is also 30 degrees. Fine. So here we have found that angle of reflection is 30 degrees. Let us take that equation number 2. This is equation number. This is equation number 1. Yes. Now, one more thing is, as I've mentioned you, the normal is in place. I hope you got the point. The normal makes 90 degrees with its way. So what can we conclude from here? Angle X. I mean, the sum of the angle made by the reflected ray and the plane and the angle made by the normal and the reflected ray should be equal to 90 degrees. So here, angle X plus angle of reflection is 30 degrees should be equal to 90 degrees. So X equals to 90 minus 30 and X equals to 60, which is 60 degrees. So the angle between the reflected ray and the plane, which was asked, is 60 degrees. So this is how we solve problems based on reflection and laws of reflection. Yes, we can have a small recap of the question again and the answer. Yes. I'm done with my topic and I'm ready for questions.
Okay, so thank you, Srilekha. We have some questions for you. Would like to ask you that, okay, so when you're explaining about a lot of examples on the mirror symmetry and reflection, so does a mirror show you a true reflection?
Yes, I can't say that it will show the true reflection because it shows lateral inversion actually. What does lateral inversion mean? Is showing the objects from right to left and left to right. As I've mentioned in the class, when we stand before the mirror, our image is not true. I mean, it's not about people look at us. It's not about how people look at us. The image that people look at us and the image which is formed inside the mirror is not identical. So I can't particularly mention that it's a true image of what we look.
Okay, fine. Because like whenever you're talking about the mirror, the one thing that struck me was our mobile phone's front camera. Okay.
Yes, ma'am. Front camera.
So like so the mirror symmetry and our mobile front camera, are they both same? Like can we
Exactly identical.
so
The mirror symmetry shows the lateral inversion of us in a mirror. And in the same way, the front camera of the mobile we use shows the lateral inversion of us. So example is, you just take a friend with you and stand in front of the mirror. And you can find a little difference in your face of friend when you look at him because his actual image doesn't seem to be identical with the image which is found inside the mirror. Yes. Hope you are clear with your doubt.
Yes, thank you. And also, how many reflection symmetries does a square have? Because you are also giving an example of a square.
Yes. Of course, I've mentioned this in class. Now
Yeah.
I'm going to do it again.
Yeah.
So here is a square. How can we divide the square into equal parts? How many equal parts can the square be divided? Yes. The first one is in a vertical way. When you fold this figure in a vertical way, yes, it's exactly matching. It has one line. Now coming to the second way, let's do it horizontally. Yes. It's matching again. We have two lines. Now let's try another way, diagonal way. It's matching again. Three lines. And then now let's go with right diagonal. Oh my goodness, it's matching again. We have 4 lines of symmetry for a square. Yes.
Yes, thank you, Srilekha. We are done.
Thank you, ma'am. And finally, I just want to thank my mentor teacher, my principal, and more or less our secretary sir for giving me such a wonderful opportunity. Thank you, ma'am. Very blessed.